Good morning, St. Genevieve class, and a happy Tuesday to you. Now, my challenge to you last week was to invent an insect. If you remember, we looked at what made an insect. So how can one classify an insect as an insect? What's special or specific to insects? And also we spoke about habitat, so where they lived and how that impacted or affected how they developed and lived. And then going on from that, adaptation. So thinking about how your insect has adapted over thousands, possibly millions of years to be able to survive fully and freely in the habitat that they live in. So what parts of their body or what part of their instinct or nature or hunting behavior has maybe changed and developed over the years to give them a much better chance at survival. Now, going on from adaptation, just to start this morning, I've found some amazing examples of adaptations. So I'd just like to share them with you. So I'm just going to grab this little guy as before and pop you down here. As you can see, today we're speaking about amazing adaptations. Just a reminder, what is an adaptation? An adaptation is something that makes a living thing suited to its habitat and helps it to survive. This could include physical features, including colour, body shape, body covering, or behaviour, something an animal does. We're going to look at some insects from across the world. For each one, try and identify at least one physical adaptation. We'll also find out some more of the interesting behaviours they have to help them in their habitats. So I'm going to show you some pictures of insects from all around the world, and I'm going to give you a couple of minutes just to have a look at them and try to work out at least one physical. So thinking about the way they look, how have they adapted a part of their body, their outside body, according to their habitat. And as I said, to give them a much better chance of survival. Okay, so our first one, stag beetle. A stag beetle lives in woodland areas. What adaptations can you identify? Remember, thinking of an insect. We have 6 jointed legs. 3 parts of the body: head, thorax, and abdomen. We have an exoskeleton. But looking at Mr. Stag Beetle, can you see any adaptations that may have taken place over years and years and years of evolution? Let's have a look. Now you can see the hard exoskeleton, which protects the delicate wings underneath and makes the beetle more difficult for predators to eat. Male stag beetles have large jaws for fighting each other and to display to females. Brown body to camouflage with surroundings. And legs with hooked feet for climbing over tree stumps and logs. So there we have 4 examples of amazing adaptations. A stag beetle larva eating rotting wood. Female stag beetles lay their eggs in rotting wood, including logs and tree stumps. The larvae hatch out and remain in the wood for around 6 years. This protects their soft bodies from predators until they are ready to transform into an adult stag beetle. Looking at another insect, Maclay's spectre stick insect, a tree-dwelling stick insect found in Australia. This one is a female. Can you think of any adaptations this stick insect has? Or can you see anything about its body that may have adapted to survival, for survival, over years and years and years and years? can see its spiky exoskeleton. So if you look carefully on its back, all the way down its back, so its head, thorax and abdomen, the spiky exoskeleton is there for protection against predators. It has a brown body to camouflage with the branches of trees and hooked toes for climbing. The stick insect sways from side to side to mimic the natural movement of wind in the leaves. Females curl up at the end of their end of the body when threatened, which makes them look like a scorpion. So this section of the body curls up, as it says. Females curl up the end of their body when threatened, which makes them look like a scorpion. How might that help them? Looking like a scorpion. What do you think? That's right, scorpion is quite a well-known predator. So it might scare off some insects or species who we might normally be able to eat up our stick insect for breakfast. Moving on, thorn bugs. These insects are found in subtropical areas from South America to Florida. They live on fruit trees. The spiky shape of the thorn bug makes them look like part of the plant, as well as making them difficult for other animals to eat. Have a look at the imagine that's very sharp to touch as well. Wings help them fly from plant to plant in search of food or a mate. We can't see it in the picture, but their mouths are like sharp straws to pierce the plant stem and suck out sap. They use vibrations to communicate to each other where the good food sources are, or to warn of predators fast approaching. Giant waterbug. Now this freshwater insect is from Southeast Asia. Now looking at its body, can you see any adaptations? Now thinking it's called a waterbug, I'd imagine it lives on or near water. Does anything there, looking at its body, give you a clue as to what might help it if it's in or on the water? Let's find out. Large, strong front legs for grasping prey. They can eat fish, turtles and frogs. Wow. They use sucking mouth parts to feed. In some places, they're called toe biters. Large eyes for seeing in dark water. Breathing tube to remain underwater when needing air. And flattened back legs for swimming. Now the Atlas moth. Tropical forests of Southeast Asia. One of the largest moths in the world, growing up to 27 centimeters across. Wow, 27 centimeters. Now, the normal big rulers that we used at school, they are normally 30 centimeters. But I've got a 15 centimeter ruler here. That's 15 centimeters there and 15 centimeters there. So actually this picture isn't far from the truth. So the actual real life versions may be about that across when they're fully grown. 27 centimeters across. Their adaptations. The tips of their wings look like snakes' heads. Wow, it's true. To deter predators. The feathered antennae for smelling where females are, so that males who may want to mate and attract females can sense where they are. As caterpillars, they spray smelly liquid when threatened to protect themselves. Now going on again, the owl butterfly. These butterflies are from South America. live on banana trees and in rainforests. Now, looking at its body, thinking about its name, owl butterfly, how has that butterfly adapted over years and years and years to aid and assist its survival? What do you think? What ideas can you get from that picture? Let's have a look. Like other butterflies, the owl butterfly has a tongue called a proboscis for sucking the juice out of fruit. It can be extended when needed and curled up when flying or resting. The top side of the wings are blue and grey, but when resting, the underside shows a pattern that looks like large eyes, possibly large owl eyes, a possible way to deter predators. Unlike most butterflies, these fly when it's dark. Now, flying in the dark, do you think this is helpful to the butterfly? Why? Or why not? Well, I'd imagine under the cover of darkness, they'll be a lot safer. So that's one element of protection. But maybe in the daylight, you might see more. So there might be a balancing act there. But as these do fly in the dark, making them nocturnal, like the owl itself. So from a distance, it could actually look like an owl taking flight. So a lot of smaller predators than the owl, but larger than the insect, the butterfly, might think it's actually an owl and take suitable measures to escape. The giant swallowtail caterpillar, found in North America. Now, looking at this little creature, believe it or not, that is a caterpillar. It looks rather disgusting, but maybe it's changed to look like that over years and years and years. Why do you think the caterpillar may have adapted and changed so it looks like that? Let's find out. This caterpillar looks like bird droppings. That's right, the caterpillar looks like bird poo. The red part is called an osmeterium, and it comes out when the caterpillar is threatened. Some think it looks like a snake's tongue, another way to scare off predators. Giant hissing cockroach. This is found on the forest floor of rainforests in Madagascar. Now, if it's on the floor, the forest floor, in rainforests, how has it adapted? Can you spot any adaptations, physical adaptations, that have helped it survive this long? Now, it has a flattened body for crawling under logs and leaves. Brown body to camouflage with forest floor. Body segments make them more flexible so they can fit into tight spaces. Spiky legs for grip when climbing and for defense. Head protected under a hard helmet. Almost like a big helmet here, you can see it right there. When threatened, this cockroach pushes air out of tiny breathing tubes on its body to make a loud hissing sound to scare off predators. Perhaps the hissing might sound like a snake. Deathshead hawkmoth, or should that be Deathshead hawkmoth? Found in gardens across Europe. Eats honey from beehives without being stung. Now, looking at the way it's adapted, how can you imagine, or how do you think this hawkmoth can manage to get into a beehive and eat the honey without being stung? How do you reckon? Maybe look at its coloration and the patterns. It's very distinct. The face pattern on the thorax, we can see almost two eyes just there. Some scientists think it looks like a worker bee head, which helps the moth get into the beehive without getting attacked. Yellow and black stripy body makes it look like something that stings, a bee or a wasp, which keeps predators away. It may also act as a disguise when accessing beehives, so that is maybe how it can get into the beehive and eat the honey. The moth has a flap on its head, which it uses to make a squeaking sound, like a queen bee. Scientists think this could help them enter the hive. So going on then, just a quick reminder. So that could give you some ideas for adaptations if you're still working on your insect. There's incredible insects we've just looked at from all over the world. But remembering what makes an insect an insect. All insects have an exoskeleton, 3 body segments, a head, thorax and abdomen, 6 jointed legs, 2 compound eyes and 2 antennae. Most insects have wings, usually 4, and most insects also have simple eyes or ocelli. And on our diagram we can see at the top there, antennae, head, ocelli, compound eye, wings, jointed legs, thorax and abdomen. A reminder of our topic vocabulary, the technical language we need. Abdomen, adaptation, antennae or antenna, arthropods, compound eyes, entomologist, remember we are now all budding entomologists, exoskeleton, habitat, head, larva or larvae, mandibles, metamorphosis, and thorax. So like we have said in the past, if you need more time to look at the meanings, the definitions of those words, please do feel free to pause the video. And finally, a little activity to go with today's lesson. A More About Me bug dial. Now, I will attach this template as PDF onto the St. Joseph class tile, if you have a look there. Now, when you print this dial, I'll just show you this one. So this is a More About Me bug dial, and what group bug dial, and also what I'm going to add to the class tile, the St. Joseph class tile, are some templates of insects that you can actually make up yourself. I think there's 6 of them. That we have a bee, there's also a spider there. But if I just pop you back to the More About Me bug dial. So when you print the More About Me bug dial, it will look as so, but in time-honored fashion. And I actually get to say, a la Blue Peter, here's one I prepared earlier, that when you cut both sections out carefully, then you may need to get some of these. They are split pins. If you remember, they go through paper, and you can hold different pieces of paper together, as so. Then the idea is you can point the pointer at a different type of insect. So for instance, spider. And if you look at the other section here, you can see the definitions. So it gives you the habitat, facts about the body, number of body sections, a number of legs. And it goes through that for each different type of insect. The what group bug dial is very similar. Again, need to be more careful cutting this one out because it has a gap there. You might need a craft knife, so you might need some extra care and attention, or even an adult to do that for you. And for this one, the idea is what group. So if you look at arthropod, for instance, and go over to the open section, it tells you that arthropods have a hard outer body, case or exoskeleton, and several pairs of jointed legs. And then finally, with the templates of the insects, you can have a go at cutting out and putting them together carefully. Again, split pins like these ones are your best bet. So hopefully those incredible creatures from all around the world will inspire you to even make your creations even more adapted or full of adaptations. So I hope you are enjoying finding out about insects and you've had a go at inventing your own. So maybe if you have one in the pipeline that you'd like to make now, please do so. Like I said, if you want to email any work to stjoseph@stjohnshorsham.school, our class email address, I would really, really love to see what you come up with. And then I will leave you with that knowledge to think about and ponder, and I will see you again on Thursday. Bye for now.